Hello students, welcome to the second year Computer Engineering and Information Technology for the data structure using C subject, and our subject code is 22317. Now we will see the today's video's learning outcomes. The today's video's learning outcomes are the sorting methods. These are the two sorting methods, selection sort and insertion sort. We will going to learn about the selection sort and the insertion sort. Okay. Now selection sort is our second type of sorting. First is our bubble sort technique. The selection sort algorithm sorts an array by repeatedly finding the minimum element considering the ascending order from unsorted part and putting it at the beginning. Selection sort is the easiest method of sorting to sort the data in the ascending order. In this selection sort, zeroth element is compared with all other elements. If the zeroth element is found to be greater, then swapping will be done. The algorithm maintains the two subarray in the given array. The first is the subarray which is already sorted, and the remaining subarray which is unsorted. In every iteration of selection sort, the minimum element considering the ascending order zeroth element is compared with all the other elements. Now we will see the selection sort algorithm. Starting from the first element, we search the smallest element in the array and replaced with the element in the first position. Then move on the second position and look for the smallest element present in the subarray, starting from the index 1 till the last index. We replace the element at the second position in the original array, or we can say at the first position in the subarray with the second smallest element. This is the repeated until array is completely sorted. Now the implementation of selection sort. This is the C implementation of selection sort. This is void selection sort, integer a, integer n. This is the for loop, integer I is equal to n minus 1, I is greater than or equal to 1, I decrement. In the opening curly brace, integer max I dx equals to I. For integer j is equal to 0, j is less than I, j plus plus. If a of j is greater than or equal to a of max I dx, then max I dx is equal to j. Means we can swap here the element after comparing. This is the swap function, swap a of I, a of max I dx. These statements used for search the maximum element in the array, and this is the function which is used for swap the maximum element with the last atom of I. Now we will see one example of selection sort. This is the unsorted array. A of 0 at A of 0 there is 55, at A of 1 there is 25, at A of 2 this is 5, at A of 3 this is 15, at A of 4 this is 35. This is the unsorted array. As we know, the number of passes required for the sorting algorithms is n minus 1. The total number of elements are 5. Then we require the 4 passes. Now we will go for the pass 1. Here in this pass 1, this is the unsorted list. 55, 25, 5, 15, 35. 55 and 25 is compared. 55 is greater than 25, that's why we swap these elements. And then 25, 55. After iteration 1, we will get this list. 25, 55, 5, 15 and 35. Now in the next iteration, we have to compare the first element, means 25 element, with the next element. This is 5. Now 25 is greater than 5, so swapping will be done. Now the new list is 5, 55, 25, 15 and 35. Again we have to compare the first element with the next ith element. Next ith element is 15. 5 is less than 15, so no swapping done, means no interchange. Then next iteration, in the next iteration, 5, 55, 25, 15 and 35. Now 5, first element 5 and the last element 35 is compared. In this, no swapping, because 5 is less than 35, so there is not swapping. Now we will get this the list after pass 1. After pass 1, first element is sorted element. 5, 55, 25, 15, 35. After pass 1, we will get this list. Now we will go in pass 2. In pass 2, now we have to compare the second element with the third element. Now this and in next iteration, second element with the fourth element, like this. Now we will compare 55 with 25. 55 is greater than 25, so swapping will be done. 25, 55, 15, 35. Now we will compare the second element with the fourth element. 25 and 15. 25 is greater than 15, that's why 15 will be get here and 25 will be here. Now we will get the list 15, 55, 25, 35. Now in the last iteration, we have to compare the second element with the last element, 15 and 35. 15 is less than 35, so no interchange. Now after pass 2, we got two sorted elements, that is 5 and 15, and these are the three unsorted elements. Now we will go for pass 3. In the pass 3, these are the two elements already sorted. This is the one subarray which has the sorted list, and this is this another subarray which has the unsorted list. Now we have to compare the third element with the fourth element. Now 55 is compared with 25. As 55 is greater than 25, then swapping will be done. And 25, 55, 35. Now this 25 is compared with the 35. 25 is less than 35, so no exchange. After pass 3, we will get 3 sorted elements and 2 unsorted elements. Now we will go for pass 4. This is the last pass. In the pass 4, there is only one iteration and only one comparison, that is the fourth element is compared with the fifth element. 55 is compared with 35. 55 is greater than 35, that's why there is an interchange, swapping will be done. Now we will get this the sorted list, 5, 15, 25, 55 and 35. This is the sorted list after pass 4. In this way, we got the sorted list in pass 4. If there are 6 elements, then the number of passes are required 5. Means we have to remind that the number of passes will be n-1, and number of comparison in each passes is n-1, n-2, n-3. Means for pass 1 there is a n-1, for pass 2 there is a n-2, like this. Okay. Now we will see the another example of selection sort. See, this is the 20, 12, 10, 15 and 2. In the pass 1, first element is compared with the another elements. Means 12 is compared with 12, then another 10, then in next step there is 15. Then first element is compared with the last element. Means we have to remind that in pass 1, first element is compared with the next elements. See, this is example. Now after pass 1, we will get this list. Then with this list, we are going to sort the another elements. Now this is 20 and 12. 20 is greater than 12, so exchanging. So here it's 12. Now 12 is compared with 15. 12 is less than 15, and that's why no swapping. 12, now 12 is compared with the last element. 12 is greater than 10, so no, sorry, 12 is greater than 10, so there is an exchange in these elements. Now we will get this list after pass 2. In pass 3, there is a third element compared with the fourth, and the third element compared with the fifth. This list, after this we will get this list. Okay, and in pass 4, in pass 4 we get the sorted element list: 2, 10, 12, 20 and 15. These are the last two elements compared. Here 20 is greater than 50, that's why the swapping done. And so we will get this sorted list. You can solve this example by yourself. Now we will see the program for selection sort. As we know, this is a header files: stdio.h, conio.h, math.h, and in main function we are going to declare the variables, that is integer, and this is array. These are the variables n, I, t, j, pass, and after that this is the clear screen function. Now we will enter the size of array by user, and then we enter the elements by user. This for loop is for the entering the elements by the user. Scanf, which is accepting the user value. Now for comparison, for pass is equal to 0, pass is less than n minus 1, pass plus plus. For j is equal to pass plus 1, j is less than n, j increment. Means now we will going to compare this condition. Now if a of pass is greater than a of j, then the swapping t is equal to a of pass is equal to a of j, and a of j is equal to t. This is the temporary variable which holds the value for the temporary. Now the closing brace, this is if closing brace, this is for loop closing brace, and this is also for loop closing brace. Now we will print the sorted elements. Then we will see the output of this program. This is the output of this program. Enter the size of array. I have entered 5. Then these are the elements: 12, 31, 45, 22, 9. And these are the sorted elements: 9, 12, 22, 31, 45. Okay. In this way, we can implement the insertion sort using C. Sorry, selection sort. That was selection sort. Now we will see the insertion sort technique. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. The array is virtually split into a sorted and unsorted part. Value from the unsorted part are picked and placed at the correct position in the sorted part. Now we will see the insertion sort algorithm. To sort an array of size n in ascending order. Here n in ascending order means numbers. First, iterate from array of 1 to array of n over the array. Compare the current element key to its predecessors. If the key element is smaller than its predecessor, compare it to the element before. Move the greater element one position up to the make space for the swapped element. This is the insertion sort implementation. Void insertion sort integer a, integer n. For I is equal to 1, I is less than n, I plus plus. Integer next is equal to a of I, integer j. Means next item to be inserted here. Now this for loop is for shift sorted item to make the place for next. This is for shifting. For j is equal to I minus 1, j is greater than or equal to 0 and a of j is greater than next, then j decrement, and a of j plus I is equal to a of j. This is the shifting. Then a of j plus 1 is equal to next. Insert the next to the correct location. This is the C implementation of insertion sort. And now we will see the insertion sort example. This is the example for the insertion sort. These are the 5 elements. This is 23, 50, 29, 11 and 1. These are the unsorted list. This is the unsorted list and these are the unsorted elements. Now there is a number of elements are 5. Now that's why we need the total number of passes, that is 4. In minus 1 means 5 minus 4. Sorry, 5 minus 1 means 4. We require the 4 number of passes. In pass 1, first element 23. In pass 1, compare the element 15 with the element 23. As 15 is smaller than the 23, so place 15 at a of zeros and move the element at a of 0 equal to 23. Means one position to the right. This is one position to the right. Now compare the element at a of 2 is equal to 29 with the element a of 0, 15. A of 0, 15. Then 29 is greater than 15, so don't do anything. Then compare the a of 2 equal to 29 with the element a of 1 is equal to 23. As the 29 is greater than 23, don't do anything. Means in the past 2, we have to compare this element 29 with the first element, then after the second element. Now in pass 3, we have to compare the element 11 with the first element 15. Now compare the element 11 with the element 15. As the 11 is less than 15, so insert an element 11 at the a of zeros. Insert this element at the a of zeros here. Then and all the elements from a0 to a2 position are moved to right by one position. Means these elements are shifted towards this position, this right position. Means here we get the 11, 15, 23, 29 and 1. After pass 3, our list is 11, 15, 23, 29 and 1. Now in pass 4, the last element 1 is compared with the first element. As the 11 is greater than 1, so that we can place the 1 at the a of 0th place and all of the elements are shifted to the right position. Then we will get the sorted list. Sorted list is 1, 11, 15, 23 and 29. Means that's why it is called as the insertion sort, because as the condition true for the particular comparison, then we have to insert the element at that particular position and remaining elements are moved to the right position. In this way we can get the sorted array element list. Now we will see the second insertion sort example. This is 23, 1, 10, 5, 2. Then after first pass, this 23 is compared with 1. Obvious, 1 is less than 23. That's why we are going to place here 20. We are going to place the 1 here, and 23, 10, 5 and 2. And shifting will be done. Now in the next position, in the next pass, next element is compared with the first element. It's like this. Comparison will be done. Then after pass 1 we will get 23, 1, 10, 5 and 2. Then after pass 2 we will get 1, 23, 10, 5 and 2. After pass 3 we will get 1, 10, 23, 5 and 2. In pass 4, 1, 5, 10, 23, 2. In pass 5, 1, 2, 5, 10, 23. Means the concept is what? Insert the element which satisfy the particular condition, and remaining elements shift towards the right. Okay. Now we will see the implementation of insertion sort method. These are the header files. This is the main program. This is the variable declaration, and these are the printf and scanf statements. This is printf for entering the size of array. Second printf is for entering the elements in the array. This is for loop for entering the elements in the array. Now this is the condition. For pass is equal to 0, pass is less than n, equal to pass increment. J is equal to 0, j is less than pass, j increment. If a of j is greater than a of pass, then a is equal to a of j is equal to a of pass, and a of pass is equal to t. But for shifting, we have to write one more for loop. For k is equal to pass, k is less than j, k decrement. A of k is equal to a of k minus 1, and a of k minus 1 is equal to t. And this is for the shifting. Now the output, this for loop is for to print the output of the insertion sort. Now we will see the output of the insertion sort. This is the output of the insertion sort. Enter the size of array, enter the elements of array. These are the elements 78, 9, 43, 6, 50. The sorted elements list using the insertion sort method is 6, 9, 43, 50, 78. In this way we have studied insertion sort method and selection sort method. Thank you.